On the top of the notes on page 2, I have the 3 different row operations used to transform matrices. The first is times row. In this case, we would multiply a row by a non-zero constant and replace the current row values with the products found by multiplying by the non-zero constant. And the abbreviation for this is A, that's the multiplier, times row I. So for example, I could multiply 3 times row 2, and that would be the abbreviation for the row operation. The second row operation I have listed here is times row plus, which is probably the most difficult row operation that there is. And this is similar to what we did when we solved systems of equations using the addition/elimination method. So for example, if I had a system of equations like 2x plus 3y equals 6 and 4x minus 7y equals 15, I would need to multiply the first row by, say, a -2 to get the x values to eliminate. So what I would have written if we were solving systems here is that first row gets multiplied by -2. So when I do that, I get -4x minus 6y equals -12. And then I'm just going to copy that second equation, 4x minus 7y equals 15, so that when I add these two together, the x's got eliminated, and I get y, -13y, equals 3. So therefore y would equal -3/13. And I could continue that on by plugging y into one of the original equations and solving for x. What we did here was we multiplied a row by a non-zero constant, and we added those values, those products, to another row. This is times row plus. And the abbreviation here is row I plus A times row J. Please note the changing row is always written first in row operations. So if I wanted to represent the row operation that I performed here with an abbreviation, I would say that we're multiplying -2 times row 1, and we're adding that to row 2. So the new row 2 values would be 0x minus 13y equals 3. Finally, the third row operation that we will use to solve systems of equations or matrices using the Gauss Jordan elimination method is to interchange two rows. And for example, I could write row 1 with arrows pointing in both directions, indicating the interchange or changing the position of row 1 and row 2.